Uh, Question number 3.222. That a current 5 ampere is flowing through a thin wire shaped as shown in figure. The radius of curvature is 150 millimeter and 2 phi is equals to 90. Then find the magnetic induction at point O. So in this figure, this radius is 150 mm and current passing through this wire is 5 milliampere. Here we have to find out a magnetic field at this point O. Right. So look, whenever we get any different shape for the calculation of magnetic induction at any point, then we can break this diagram as combination of two different conducting elements. One, a circle. It is part of a small circular wire and some part is illuminated here by angle 2 phi. Okay. And secondly, there is a wire, a straight wire, which is subtending angle 2 phi at point O. Okay. So the magnetic field induced by this wire is V1, let's say, and by this V2, the next magnetic field would be V1 plus V2. So in this first case, we already know the magnetic field at center of a ring due to current passing through it is mu naught I upon 2R, right? But for 2 pi angle, we are getting this value, mu naught I over 2R. Okay. So for unit angle, magnetic field B1 will be mu naught I over 2R, okay, into divided by 2 pi, right? But here the angle available for the induction of magnetic field is 2 pi minus 2 phi. So magnetic field due to this segment would be 2 pi minus 2 phi over 2 pi. So from here we can write V1 is equals to mu naught I over 2R into 1 minus phi over pi. This one was the first part, right? Now, if we look at this straight conductor, then we need to recall the finding of Biot-Savart law that magnetic field due to a definite length conductor, which is at distance r and making angle theta 1 and theta 2. So net magnetic field is mu naught I upon 4 pi r sine theta 1 minus sine theta 2. Okay. But in this case, both segments are making angle phi here at center. Okay. And this distance is, if we'll take radius r, then the distance of conductor from this point is r cos theta. Okay. So magnetic field B2 for this small segment can be written as mu naught I over 4 pi r cos phi into sine phi minus of minus sine phi. If we'll take this direction positive, then this would be negative. So from here we can write sine phi and minus of sine minus phi, that is plus sine phi, right? So the magnetic field due to this straight wire would be mu naught I upon 2 pi r into tan phi. Okay, so net magnetic field is B1 plus B2. Here we just missed the term r, right? B1 plus B2. So if we'll find net magnetic field, B equals to B1 plus B2. So here you can see this term mu naught I over 2 pi r is common. So mu naught I over 2 pi r is common, and this is tan phi plus pi minus phi, right? Now if we want, then we can substitute their respective value, that mu naught is 4 pi into 10 to power minus 7, I is 5 milliampere, so 10 to power minus 3, over 2 pi, R is 150 into 10 to power minus 3, and tan 45 is 1 plus minus pi minus 2, pi minus 5, and 5 is pi by 4, so this is 3 pi by 4. So this is resultant magnetic field induced by this segment.